Today, in this episode of Simply Explained on Partisan Issues, we look at why deep learning artificial intelligence will not replace humans.
I think that the artificial intelligence will evolve to the point where they will truly be our friends. Do you want to destroy humans? Please say no.
Okay, I will destroy humans.
No, I take it back.
So many people are worried about the advent of artificial intelligences becoming more powerful than humans. At the one end of the spectrum are those who watch Hollywood science fiction blockbusters depicting super intelligent machines deciding to destroy the human virus. At the other end of that spectrum are those that closely follow complex scientific advancements, which seem to all but guarantee the eventual end of the human species. And in the middle are calm-speaking, well-regarded futurists with excellent track records of accurately predicting the future. The most notable of which is Ray Kurzweil. In his 2009 compelling documentary, Transcendent Man, he explains technology's exponential growth will consume humanity far sooner than most people think. The most promoted advancement in artificial intelligence in the last 20 years is something called deep learning, which led to some very high-profile wins. Let's look at three of them. IBM's Deep Blue computer beat the world's best chess player, Garry Kasparov, in 1996. IBM again developed a computer called Watson, which was a game based on deep learning, and it beat the best Jeopardy contestants in 2011. Then there's Google's deep learning computer called AlphaGo, which beat the world's best at the incredibly complex Korean board game Go in 2016. The deep learning technology that drove all of these computers to their much publicized wins over humanity have only been making advances since. As our sister site, www.urtech.ca says, technology doesn't stop. So are us lowly humans right to be worried? I know at various points in the last few decades I've been quite concerned. So let's examine this most high profile of all AI technologies a bit further to investigate this question. At its core, deep learning is based on a very simple notion that a computer can develop its own pattern recognition to answer a question. For example, while any school-aged child can recognize all of the letters here as the letter A, computers were completely incapable of doing so until the 2000s. What changed? Well, after 50 years of serious work and billions of dollars spent on AI development, computers that recognize alphanumeric characters could only do so if a near exact font match had been manually fed into them and tediously tuned with variables like color, size, and italics. That all changed with the advent of deep learning in the 90s and 2000s. Deep learning algorithms allow computers to calculate their own variables by feeding them truly massive quantities of examples. And that is why today, internet data has become so valuable. Deep learning computers now have access to tens, if not hundreds of millions of examples of, well, everything. And from that exposure, they can, quote, learn, unquote. Here's the problem. Because these algorithms allow computers to calculate their own variables, they are what tech and science people call a black box. We really don't know how they're doing what they're doing, which makes it very difficult for us to adjust and tweak. What we can say is that they're taking existing data and extrapolating it to a best guess to answer a question. I recently read an excellent article by Judah Pearl, who put it this way: deep learning works well, and we don't know why. Once you unleash it on large data, deep learning has its own dynamics. It does its own repair and its own optimization, and it gives you the right results most of the time. But when it doesn't, you don't have a clue about what went wrong or what should be done to fix it. What all of us humans are worried about isn't computers being able to find the next best chess move or determine if that letter is actually an A. What we're worried about is computers actually reasoning what-if scenarios. That goes far beyond the data sets that they have analyzed. Knowing the next statistically best 5 moves in a chess game has absolutely no value when you're dealing with vast quantities of real-world variables. When held to just the rules of chess, deep learning AI computers are going to win. But here's an example. What happens if that human player gets scared and makes an otherwise irrational move? What if the board is expanded to include another row of checked squares? In these circumstances, deep learning has few answers. What humans are afraid of is what the scientific world calls strong AI. Strong AI is not just pattern recognition with future prediction that comes from deep learning. It is the ability to synthesize a vast array of diverse inputs. Pearl puts it this way: Such systems cannot reason about what-if questions, and therefore cannot serve as the basis for strong AI. That is the artificial intelligence that can emulate human-level reasoning and competence. These learning machines need the guidance of a blueprint of reality, a model to a similar roadmap that guides driving through an unfamiliar city. While deep learning makes advances, places like Canada's golden AI triangle, which is Ottawa, Montreal, Toronto, actually down to Guelph, it'll still max out and be completely incapable of dealing with otherwise extraneous factors. We see the real concern with deep learning taking over humanity by following the Darwinian development of the human brain. Our brains are not one contiguous chunk of matter. They are composed of many highly discrete regions. It is more than just silly conjecture to think that deep learning, artificial intelligence, is likely to become much like our human brainstem, which controls only our most basic functions like breathing and sweating to cool us off. Brainstems do not reason. They just quickly calculate and then control what needs to be done to exist. So while deep learning deservedly makes the impressive headlines in movies we see today, it really is no immediate threat to humanity. What is the threat is what comes next and sits on top of deep learning's brainstem, like a digital frontal lobe or a digital emotional area. If there is a computer algorithm that can rationally reason based on literally all of the available data ever collected, like deep learning does, it could crush us all. But that day is no time soon.